Hello everybody, you're very welcome to this episode of Programming and Algorithms. In this episode we're going to look at how to program the Google search. In particular we're going to look at the web crawling element of how Google works. So we said it before, if we want to see how Google search works, there's a few different bits to it. We know that the Google Corporation sends computer programs around the web called spiders. Those spiders crawl around the web, go to a page, look at all the links in that page, jump to all of those links, from that page jump to all the other links, and link around. Crawling is a kind of hit and miss operation in a way. Sometimes it works very well if your start page has lots of links on it. But if you start on a page that has no links on it, your crawl goes nowhere. Another thing it does when it finds a page is it scans what words and phrases are in the page. So if I search for the word banana, and then it has in its records a page that has the word banana several thousand times in it, it probably knows that page is about bananas. So storing a word count and doing a bit of analysis is very important. And the other thing it does, I guess, which is really key, is it looks at the importance of a page on the basis of how much it is linked to by other pages that it views as important. So it's a kind of recommendation almost process. So if I have a web page that is credible, like a government website or a newspaper page or something like that, and it links to my page, then it automatically increases my ranking. So when you search for my page, it'll be higher up in the ranking if I'm linked to by more and more credible sources. So really it's important to realize that linking pages, how we get from one page to another, is key in terms of how Google works. So really to help us understand this, we're going to look at HTML, and we're going to look at just the basics of HTML. So believe it or not, the easiest way to create a web page is just go into Notepad and type in a phrase in Notepad. Instead of saving the file as a .txt, save it as a .html, so call it firstpage.html. And then if you open that page in a browser, you've got it. It's going to display whatever text. So if you put in the phrase, this is a web page, it'll display the text, this is a web page. So that's how it works. A HTML or a web page is just a text file. Now mostly the web pages have special tags in them to display information in special ways, but in general it's simply a bit of text. So you're looking at a notepad file almost all the time. If I look at the structure of a web page, a good, well-structured web page should open with a tag, which is open angle bracket HTML close angle bracket, and then at the very bottom of the page it should say open angle bracket slash HTML close angle bracket. So all tags in HTML work like that. They open with whatever the word is and they close with a slash in front of it. So that tells our browser that it's a HTML page. As we saw, the browser doesn't necessarily need that, but it's good to give it a clue in terms of what kind of page it is. And typically web pages have two parts within the HTML. They've got a head and a body. So to say something is a head within a HTML, we just say it's open angle bracket head, close angle bracket, and then slash head to close it. And for a body, it's body and slash body. Now in my mind, when I explain the difference between a head and a body in a HTML web page, how I think of it, it's like the head is like an envelope and the body is like the letter. If I'm sending somebody a letter, I usually wrap it in an envelope. The letter is the bit you can read and see. So for a web page, whatever's in the body of the web page is what you can see, whereas the head or header information, it just describes some information about the letter, as the analogy would go. So the envelope will tell us probably who the addressee is. If it has a return to on the back, it tells us who it came from. It has stamps, which indicates how much it cost to send it. It probably has post office stamping on top of the stamps, which tells us what route it took and things like that. So there's a lot of meta information, we might call it more information about the letter that's contained within the envelope. And in the same way with a web page, the header information, it typically isn't displayed in the browser window, but it typically is about the web page. So it describes information like the language the page is in, the subject of it, possibly some keywords you'd find in the web page, which is very helpful for Google, and important formatting information. So if we want to take an example, if I wanted to put something in the head, something I could put in that's very easy is I could put in a title. So that's open angle bracket title, close angle bracket, and then open slash title, close. And then I can put whatever phrase I want in between. The phrase I'm going to put in is anything you want in the blue bar. So what does that mean? What that means is if I open a notepad file and I put in HTML head title, anything you want in the blue bar, close title, close head, then open body, close HTML. What I'm saying there is, because there's nothing in the body, nothing will appear in the browser page. But in the head part, which is not in the browser page, the phrase anything you want in the blue bar will appear. Where will it appear? Well, it'll appear up on top in the blue bar. So as you can see up there, anything you want in the blue bar is the name of the page. So it's not contained within the page, but it's about the page, like the envelope is just wrapping for the page. Let's look at stuff we can do in the body. Well, simple stuff to do in the body would be, we could put in a header 1, which is, if you've ever used Microsoft Word, you know you can format H1s and H2s and things like that, so it's just a header 1. And we're going to put in the phrase header of page, and a header 2, a H2 and slash H2, which is subtitle here. So that's what that looks like in Notepad. Now we've got our title, and we've got header 1s and header 2s. But they're in the body. So if they're in the body, then if we open this in a browser, we will see header of the page and subtitle here. Search engines use those H1s and H2s to determine what the subject of the page is. So it's very important, if you're putting in a H1 and H2, to put in a sensible text in there. There's no point putting in this is a header or something silly like that. If it's about bananas, the header 1 should be bananas. And subcategories could be skin of banana or inside of banana or something like that. But the search engine will use these H1s and H2s to determine how relevant this particular page is to your search. We'll try one more thing. We could put in a special link command called ahref. So, well, the link is really A, so it's open angle bracket A, and it takes in a parameter of href. We won't worry about it. But you put a phrase, the same as before, link here is our phrase, and then we close our A/A. Now, href stands for a hypertext link reference, which means a link. So if we want to introduce a link to a page, what we're saying is, have the phrase link here on the page, and when the user clicks on the word link here, go to http://www.google.com. So that's what an ahref means. Ahref is a hypertext link reference. So this is how I create a link on a page. So again, if we see it in Notepad and then we pop into our browser, we can see the word link here in capital letters. And if we click on link here, it will bring us to google.com, because that's what a link is. So if I'm scanning through a web page, if I need to parse a web page or read through it, if I want to find what pages it links to, I just need to look for the phrase ahref equals. Whatever it's equal to, that'll be a link. That'll bring me to something else. So that's the basis of our spider or crawling, is we treat the web page as a notepad file. We look for the phrase ahref equals, and then whatever address we're linking to, we use that to link to other pages. It is worth noting here that there are 2 ways we can create links in a web page. If I want to link to a site outside of the site I'm on at the moment, so if I wanted to go to, let's say, the Star Wars homepage, http://starwars.com/index.html, we call that an absolute address. It directs me absolutely to where the new site is. But if the page I want to go to is in the current website, and indeed on the same level or in the same directory, in the same folder as the page I'm at the moment, then all I need to do is say ahref new page.html, so just state the page name. So I don't need to specify either the protocol or the site address if the current page is linked on the same page, which is great, except when we're parsing through pages, it makes it a little bit tricky, because for an absolute link, we know exactly where to go to, but for a relative link, we need to do something fiddly, and we'll see how we do that in a minute. Okay, cool. Rock and roll. Okay, so now let's look at opening a web page or URL in Python. So a URL is the term we use for a web page. It stands for Uniform Resource Locator. And typically we say a URL has three parts. If we look at starwars.com.index.html, there's the HTTP bit, which is the protocol. Typically most pages are HTTP as protocol, although some sites are secure sites, so you might see HTTPS, and some are FTP. We have a host name, in this case is www.starwars.com, and then we have a file name, which in this case is index.html. So there's three parts: the protocol, the host name, and the file name, and that's the 3 bits of a URL. In Python has a number of built-in functions or modules. For example, the print function, we know what that does. It prints stuff out. The input function to take input from the screen. The int function to convert whatever variable into an integer value. As well as those built-in, most instances of Python come with what's called the standard Python library. So that gives me access to more functions that I can use. They're not built into the core of the language, but normally when I download a version of Python, these programs come with me. Every time Python gets upgraded to a new version, 3.12 to 3.13, sometimes new modules or methods are added into the standard library. One useful function or module or method we could use is called URL open, to open a URL or web page. And it's in a collection of the library called URL-lib request, URL-lib.request. So if I want to open a URL by calling the URL open module or method, I need to state at the top of my Python program, from URL-lib.request, import URL open. So bring me in the function URL open so I can use it from the library called URL-lib.request. And that means URL-lib is available in the program. We could also say, just import URL-lib.request, which means import everything from URL-lib.request, but that's like importing, if I wanted a single book from a library, and it's like just bringing in a whole shelf. So it means if all from URL-lib.request are imported into the program, it means the program itself is a lot bigger than it needs to be. So I should only really bring in functions I need, because otherwise the compiled executable just gets bigger, if that makes sense. So normally I would say from URL-lib.request import URL open, just not to have to bring the whole thing in. And then if I open a URL, what that typically gives me is header information about a particular page. So it normally tells me the date it was created on, the last date it was modified, what kind of computer the web page is running on, what the what type server it is, what types of information does it accept, byte values, how long is the page, is 3321, the connection type, and then the content type, which is a text HTML file. So it's a HTML file. That's what URL open is telling us. So let's look at that for a second. If I do a request to a particular URL and it says it's a HTML or HTML file, that means it's a web page. But sometimes when I go I'm on a page and I have a link, and it's not to a web page, it's a link to a PDF file or an Excel sheet. I don't want my spider to go into PDF files. I don't want my spider to go into Excel spreadsheets, because it's just going to get stuck in there and it won't know how to parse, because you won't have ahref in the PDF file, you won't have ahref in the Excel spreadsheet, even if it's a link to an image or something like that. So you only want to go to a new page if you do a URL open on it and you find that the content type is HTML. So how we might do that in a program is as follows. First thing we do, as we said, is from URL-lib.request, we import URL open. Then we create our module or method called URL opener. We check if the response, we create a response by opening the URL, and then if the response of the header has content type of text.html, then we print this as a web page, and we can print out the whole header that we saw previously. Otherwise, what we'll just say is this link is not a web page. So it could be a PDF or it could be an image or something like that. So all we're doing here is we're using if statement to check if the header information, subcategory content type is HTML, text/HTML. If it is, it's a web page. If it's not, it's either one of two things, it's either a different kind of file or it is a web page, but URL open doesn't recognize it as a web page. And sometimes some web pages, because they're not identified as HTML or because they're just weirdly formatted, if you don't have that open angle bracket HTML on the top, it mightn't know it's a HTML page. So that's why it's really important to put HTML and close HTML at the end of all web pages. That's cool. That's PO. Great. Cool. Now let's look at if we have a URL, a relative address, how we create a new full URL from that. So we have another module or method called URL join, and that's in a library collection called parse. But the library is called parse and the collection is URL lib within that. So what I say is URL join, if I need it, I need to say from URL lib import parse. And one of the sub-functions within parse is URL join. So it's slightly different from the way URL open is. But anyway, parse.url join is in our Python program then. So if I have a relative address, so let's say I have a page address at the moment and it's www.cwi.nl/guido/py.html, and I have a link on that page that says on that page is a link to faq.html. That means faq.html is a relative link. So using URL join, what that means is it'll create a new URL called cwi.nl/guido faq.html. So it cuts off the web page name from the first parameter and sticks in the web page name from the second parameter. That's all it does to create a new name. So technically speaking, we're joining the base URL to a new web page. And that's really important if we have relative links as opposed to absolute links. So we need to be able to do that, and that's exactly as I've said. With the absolute link, there's no need to use URL join, but with the relative link, we have to join the current server name base URL to the new web page. Exactly. So another example, if it's dit.ie/homepage, and on home.html there's a link to a page called, there's an ahref equals new page.html, then I can create the link to that absolute address, dit/new page, simply by doing URL join. So that's an important building block in constructing a spider. And our code might look like this. Here's an example bit of code for you. If I said from URL lib, import parse, and then I'm creating an array. It's an array of web addresses as it happens. So the array is called web pages found, and we've got 4 elements in it. The 0th element is contact us, the first is main page, the second is sign up, and the third is faq.html. Those 4 elements then are, if we pass in a parameter into URL joining of a particular web page name, what it's going to do is take that web page name and then join contact us, main page, sign up, and FAQ onto that address we pass into the URL joiner method or module. So have a run of that and see how it works. Just want to say a word about a parser here. So there's certain kinds of programs that allow you to easily skip through HTML code because it's got a bunch of tags and tags embedded within tags and tags embedded within tags within tags. There are certain programs called parsers that allow you to create a tree that says, well, the title is inside the head, which is inside the HTML, and allows you to break the thing down and find particular tags, but also preserve the relationship between that tag and all the other tags in the hierarchy. So we call those programs parsers. Linguists use them as well to parse sentences. We use that phrase to parse a sentence. So this is a program to parse HTML code called a HTML parser. It just preserves the relationship between tags, which is important in a hierarchy. Cool. All right, so then creating our spider, here we go. The spider we've created from the code available takes in 3 parameters. it takes in a start page, which we're going to call Webpage. It takes in a term we're searching for, and it says a maximum number of pages. And this is very typical for a spider. So normally when you send a spider out onto the internet, you can't have it crawling forever. Otherwise, because a lot of web pages are linked to a lot of other ones. If you find a good home page to cite it on, it can keep going out. And that isn't really good for Google, because Google needs to update its searches, its information every few days. So normally it says, from this site, just link to the first 100 million pages. From this other site, just link to the first 10 million pages or whatever. But Google has refined this to a great deal, just so that your spider doesn't infinitely crawl the web. Sometimes that happens, sometimes the opposite happens. So I say, here's a home page that has no links on it, or it has just one link, and that link goes nowhere. So if I suggest a max number of pages of 10, and I go to a page that just has a link to another page and then stops, I'm only going to get 2 pages. On the other hand, if the page links to loads and loads of other pages, if I say max number of 10, it's only going to do the first 10 and then stop. And while it's visiting these pages, it's going to look for the specific search term we've specified. So in terms of our spider, what we're going to do is have an array called pages to visit, and each page we find, each link, we're going to add it into that array, pages to visit. And when that gets to max pages, then we'll stop adding values to the array. If at any point we visited all the pages on the array, pages to visit, then we know grand, we can stop, whether it's hit max or not. If it's before max, that's fine. In terms of the main loop of the spider, there's 3 things we need to check. Either have we reached the maximum number of pages, then we should stop the loop. Have we run out of pages to search, then we should stop the loop. Or have we found the particular search term we're looking for, then we can stop the loop then as well. So in terms of Python, that looks like while number of pages visited is less than the maximum number of pages, and pages left to visit is not null, so we haven't run out of pages, and we have some boolean called found word, and that as long as that's not found, then we know our spider is going to keep doing our URL open and doing our URL join and working away. And as the way we're finding the links is by using the HTML parser to jump along and see if we can find it. I will note that in the code we use a class command, the word class, to declare how the HTML parser works and things like that. We don't need to worry about what that means. You'll find out what that means next year. But just to say, for the moment, the class command is a way of declaring a version of the HTML parser that works for our program. So you don't worry about getting too hung up on the main spider module, as long as you get the fact that in the spider program there's a loop with those 3 conditions. There's a HTML parser to find links, and using that find links we use URL join and URL open to get to more and more links. And that's the general principles of the program. So that's how a spider works. You run it, play around with it, see how you get on with it. Thanks very much. We'll see you on the next episode.